Hi everyone, this is Mrs. Emmanuel coming with you for the first 9-week exam review so you can have some ideas what we're doing. Okay, we're just applying. Here we go with the first question. It's a one type of redwood tree has an average height of 65 feet when it's 20 years old. So when it's 20 years old, it's going to be 65 feet tall. Okay, average at least. If the tree is more than 20 years old, the average height H can be modeled by the function H equals 1 in 8,500 times A minus 20 plus 65, where A is the age of a tree in years. A, when it's more, well, it should be more than 100. More than 100, more than 20. That's when you should, because if it's less than 20, it's going to be negative. Okay, so you do more than 20 or 20. Okay, more than 20 or 20 is which thing about this situation true. So I'm going to make a table first. You can see I already started, and I said A greater than or equals to 20. H is for the height. A is for the age, greater than or equals to 20, because we are not going to have a negative height. Okay, keeping it real. Okay, H is the height. So here, this is really my X, and this is my F of X. Independent and dependent variable. Okay, so if I substitute 20 in, I'll get 65, because 20 minus 20 is 0. 0 times anything is 0. 0 plus 65 is 65. Then if I put 21 in there, 21 minus 20 is 1. 1 times 1 in 85 hundreds plus 65 give me 66 and 95 hundredths. Okay, and I know you're like, oh my gosh, let me write this. You're probably like, oh, I don't like decimals. Well, remember, we can use the Inspire calculator not only on our exam, but on the EOC just as well. So let's go ahead and use it. Okay, so here we go. Let me enter this function in to the Inspire calculator. Now, keep in mind, remember, A is X and H is the F of X. So we have F of X equals 1.95 times X minus 20, close the parentheses, plus 65. Okay, enter. You don't see the graph because of the 65 is up. It's up, and I have to change the domain and the range for this. Actually, the range for it, and I'm not going to do that because we want to focus on the table. We want the table. That's what's going to help us to really look at the information. So I'm press menu, go to table, split string table, and here it starts with 0. I'm going to go ahead and change that. I want it to be 20. So I'm going to edit the table setting, and I'm going to change my table start. I want to change it to 20 and enter. So now you see we got 20, 65, 21, 60, 60, 95, 100, and 60, 89, 10, and so on. And you see how it's increasing? So now I have that table, and I have a better understanding of it increasing. Maybe not rapidly, but, you know, just a tiny bit. So now let me read so I can read for understanding, so I can make sure that I get the correct answer. Every additional 1 in 8,500 feet of length over 25 feet adds 45 years to the age of this type of redwood tree. What they got to do with it? This you should be asking something like, what? What are they talking about? 45 years to the age? How's that add 45 years to the age? It didn't give us that information. Is it possible? Maybe so, but it didn't give us that information. Okay, so I'm going to mark out A. Because 45 years, it seems like it's going up by a year. That's just what it seems like. Okay. Okay. For this type of redwood tree, the average height increases by 1 in 85 feet per year throughout its lifetime. How's it doing it? Oh, so you say it increases 1 in 8,500 feet per year throughout its lifetime. Now, is that true? Could it be? Is it talking about after? Because if you look at this right here, if you look at the 65, then we add $1.95. So if we add, well, I said $1.85, I mean 1 in 8,500. If you add 1 in 8,500 to this, will I get 689 tenths? Okay, so let's see, will we get that? Because right now, let me write that down. And this is what you should do. This type of things you should do to check. When it's 23, it's 70. 70, you see what 24, I'm going to put 72 and 8/10. Okay. And what it asks us, here, it says, for this type of rate, the average height increases by this amount per year. Per year? So let's see if that's that. So we got 66.95 clear. 66.95 plus 1.9. My fingers. Enter. So that gave us 68.9. So it did give us 68.9. And then I'm going to say plus 1.95. Enter. It gave us 70. So it is increasing. It is. You then I'm put true, but let's read it. The rest of it. That's true. Okay. Each additional year of age over 20 years add 1.95 1,800 feet to the average height of this type of redwood tree. Did this say the same thing? It said the average height increases throughout its lifetime. Oh, maybe that's the key, because the part is true. This part we know is true. But is it throughout its lifetime? What happened from, when it was 20 years old, from 0 to 20, it was 65 feet. You see? So it's like you're thinking like, oh, wait. But here it said each additional years over 20. Now this right here was over 20. This over 20. So we know this, the true. We know it's true all the way. This right here where it says lifetime, throughout its lifetime, we don't know about that. Okay. So here we go. Now it said for this type of redwood, the average height increases by 65 feet for every 20 years of growth. It didn't say that. It said 1,800 feet. So this right here is false. This is just for 20 years. This is only for 20 years, not every. That's all the information we know. So now we know those two is not our answer. It's between B and C. So I would choose. Which one you think I would choose? Which one? Everything is true. C. That's exactly what I would choose. Okay. But you got to talk to the paper. Not out loud though. But I'm modeling thinking for you guys. Okay. So here we go. Going to number 2. And I like the model, the thinking, because that's what's important. You have to think through it. Just think through it. And that's what I'm doing with these problems. You probably say, you already know the answer. You got the answer key. Usually I don't look at the answer key all the time. But yes, I do have answer key, but I'm working through it. Okay? Here we go. Reading first. The table shows the population. Here's the table. Of P of the mice. In a field that shows population P. So population P. Here we go. Of mice in a field at the end of M the month. So here I know this is my X and this is my Y. You're like, why are you writing it? Because I know this is independent, this is dependent. Okay. So it said based on the data in the table, what will be the population of mice in the field at the end of 8 months? So the end of 8 months. So what I'm going to do is extend the table. See what's going on and extend it. It's at 8 months. So this says 4. I'm going to say down here, I'm going to say 5, 6, 7, 8. Okay, and this is at the end of the month. So it says 8 months. So I'm just going to continue the pattern. I'm not going to rush. I'm not going to rush over here and start working on it. Okay, they went from 6 to 12. So what are they doing? They go from 6 to 12. Add 12. From 12 to 24. Add 12. From 24 to 48. What happened? Did they add 12? And then, gosh, you see what I did here? Yeah. You see how I caught myself? Because I'm jumping down. Add 6. And that's the beauty of math. You mess up. What did I do? Go erase. I don't get mad. I think about it. I said, wait now. Here, it's added 12. And I add 12. I'm like, that's not making sense. So you go back and look. And you make changes. So we add 6. 6 plus 6 is 12. 12 plus 12 is 24. 24 plus 24 48 plus 48. So you adding, I add 48 to get it in from here to here. I'm adding 48. Okay. So here we got 96. So I know right here it's going to be 96 plus 96. Okay. What does that equals? And whatever I get there, I know it's going to go there. Okay. So you'd be like, okay, get your calculator, guys. Remember, we can use the calculators. So don't panic. Just get it and just put it in there. You see it's doubling. Okay. So here you say 96. 96. And I'm going to say times 2. Enter. And I get 192. And look, you know what? You see this? And that's for 5 months. And look over here. And I'm going to put here 5 months. They didn't ask me about 5 months. I'm looking for 8 months. So I know that F is not my answer. Okay? So you got to watch out. Because if you don't focus, it's easy for them to get you. So now this is going to be 192 plus 192. Okay? Because this right here was 48. If you need to do something like this, do it. If you said 24 plus 24, do it. It's okay. 48, 24 plus 24, 48 plus 48, 96 plus 96, 192 plus 192. So I'm going to double the 2, the 192. So I'm going to say times 2. And I get 384. Okay. So that's 384. We don't have 384 over there. If we did, it would have been for 6 months. So double 384, meaning I'm just going to put times 384 and see what I get. So I'm going to say 2 times 384, press enter. And you see that we got 768. You write down 768. That's for 7 months. We don't have that. And look, you already know the 256. It's like, what were they thinking? We know it's not 256 because we've passed it. Okay? And we know this is too small. And I mark it all the way out because I don't want to go back and make a mistake. That was for 5 months. That's too small. Okay. So now we got 768. So now we know we're going to say 2 times 768. Look, I need to slow down because I get to talking fast. So times 2, enter, and we get 1,536. Okay, that's for 8 months. So here, this is 8 months. So I know my answer is H because I'm looking for 8 months. And here, this right here, guys, if you don't watch out, if you're doing it another way, because, you know, you can come up with the equation. You really can do the equation and you can get your answer a different way. But I highly suggest the table because you're not trying to make any mistakes whatsoever. Okay? Because if you're write an equation, you may end up making a simple mistake. Because right here for 9, got 1,536 times 2. So I'm doubling that. So I times 2, enter, and I get 3,072. 3,072, and this is that. So that's for 9 months. Okay, so I know that's not the answer. So if you know what all the answers go to, it helps you to have better outcome. Okay, so just make sure that you're watching out. Watch out. Do not, or be careful. Do not just choose an answer. Go through and really analyze the information that was given to you. Okay, that was 2 problems, and yes, take longer because I'm trying to explain it, and I'm trying to let you go through. Allow you to see me go through the thinking process, allowing you to see mistakes. You probably say, do you have to make mistakes? I don't have to make mistakes, but it's okay to make mistakes. Okay, I could have worked it all out and made sure everything was perfect, but that's not how it goes. I go through the thinking process. If I make a mistake, I'm okay with it. As long as you correct it, you're okay. Okay. So here we go, number 3. Here we go with number 3. It says the graph shows the cost of purchasing X small flags at a gift shop if the flags are equally priced. Okay. X, the small flags. Okay. So it's number of, and I'm put small. Okay. To make sure we're talking about small flag because it said X. And we know this the X. It has it right here. Okay. Then below the graph, here we see this cost for our independent and dependent and our independence number of flags. Here, based on information, which order pair represent an additional point on the graph? Okay, let's see. First of all, I'm gonna make a table. Y'all probably like I'm gonna put X, Y, number of small flags. Okay, and then I'm put total cost or cost. I just put cost. Okay. Here we go. The lighting is adjusting. Sorry. So here we go. This first one, it says one. When you buy one small flag, it's $5. If you buy two, it's $9. Okay. So let me go ahead and put 5, 1, 5. Okay. 2, 9. 3, 13. 4, 17. And then I'm going to put it in the table. I needed to do it this way. I know you probably said, you said you don't put it in the table. I am. So 2, 9, 3, 13, 4, 17. Okay. So I got 1, 2, 3, 4. Okay. And now I need to see what's the pattern with my Y. Because I see I'm going here. And they went up to 8. They don't have an order 5, 6, 7, 8. So I'm going to say 5, 6, 7, 8. So I can have all of them to make sure. Okay. So I see 5 to 9. That's adding 4. 9 to 4. Add 4. 13 plus 4 is 17. So I'm going to say 17 plus 4. I'm going to keep the pattern. And I get 21. So it's 5 and 21. And they got 5 and 19. So I know this is not going to work. So now I'm going to say 21 plus 4. 21 plus 4 is 25. So 6 and 25. They say 6 and 24. That didn't work. So here, 25 plus 4. That's 29. 7 and 29. 7 and 29. This right here is my solution. Okay? To the question they asked me. I'm going to go ahead and do 8 though. 29 plus 4 is 33. And that's 34. So now I went up to 8 to match up with theirs. And the one that fit in this pattern would be 7 and 29. Okay. So don't try to rush to get your answer. You go through the process to make sure that you're doing this correctly. Okay. Number 4. Moving on. And remember, you could pause, you could rewind, you could look over again and again. You could try it on your own and then come back and look. You probably have other ways. It's so many ways. I'm not doing all the ways. Here we go. The population of a town is currently 9,000. Okay? So that's what is 9,000. Starting off. The function P equals 9,000 plus 8 times T squared can be used to estimate P, the population of the town, T, years. Okay, so what am I going to make? A table. I'm going to make a table. So where do I want to put my table? I'll put my table here. I want a table. Okay, so T, that's my independent. That's my X. Okay. And T, they say it's the years. So T, that's years. Okay. Then P is the population, which is Y. Population. Okay. It said it can be used to find based on this function which statement is true. So let me see. If it's 0 years, the initial, because remember, start off with 9,000. So that's going to be 0 squared. That's 0, 0 times 8 is 0. So it's 9,000. Because they started with that's the initial cost. Then I can go ahead to 1. After 1 year, they expect for the population to be 9,008. Because of you doing 1 squared, which 1 times 8 is 8 plus 9,000. So 8 people was added on. And you be like, oh Lord, it's going to take a long time. Exactly. What are we going to use? Inspire. So let's go put this in our Inspire menu. We want to, let me get out. Okay. New document. I don't want to save anything. I want to graph. And here we go. I'm going to put in here P, that's our f of x. Then I'm put 9,009, 1, 2, 3, plus 8x, t is our x, squared. Okay. Then I'm going to press enter. And I really want to go to the table. Okay. So I'm going to press menu and go to the table. Go to the table, split. Now the table, oh, it started off like I needed to start off with. Start off with 0, and it's 9,000, and you see it in 9,008, 9,032, 9,072, 9,128, and so on. It's going up, 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 up. So let's see what it says. The population of the town is increasing at a constant rate. Is it constant? Is it the same number over and over? Here, because it says for 2, it says 9,032. So, when it says, oh, it's 9,032. So, here, from 9,000 here, yes, I add 8. But did I add another 8 to get 9,032? Is this 9,016? So, it's not a constant rate. It's not a constant rate. So, no. It's not constant. You probably say, not adding or subtracting the same number from the y value. Okay, so what you may want to do from the y value, that's what we're looking at. Okay, so I'm going to say P, not adding or subtracting. Okay, and you see you can mark all over it. You notice I don't highlight a lot in these problems. I don't circle a lot. I look and see what it say, and then I start to focus more on making sure I understand what I'm reading. So that's what you should do. You can highlight, circle. In some cases, I will. Just letting you know. The population of the town will reach 10,000 between 11 and 12 years. Between 11 and 12 years. So you know what I'm going to do? I'm going to go back to the table, and I'm going to edit the table setting. I'm going to put 11. I'm going to put 10. Let it start at 10. Enter. So between 11 and 12, the population of the town will reach 10,000. Between 11 and 12. And if you look, you got 11 years. So 11 years. Let me put it over here. 11 years. We have 9968. For 12 years, we have 10,152 for the population. So go back and read it. The population of the town will reach 10,000 between those 2 years. Did they reach 10,000 between it? Yes, that's true. Okay. Am I going to just choose the answer? No, I'm going to read the rest to make sure that I'm reading correctly. Okay. The population of the town will increase by 256 people 2 years from now. So 2 years from now, it increased 32. Because look, it started off with 9,000, then 1 year passed by, it was 8. The second year, it was 9,032. That's not 256. So you probably say, how can we find that out? Let's go back. Let's go back. I'm going to go back. I'm going to press menu, table. And I'm going to change my setting. No, escape. Okay, let me do it again. Menu, table, edit. And I want to go back to, I'm going to say 2. Enter. So 2,256, that would be between year 5 and 6. Okay? That's between year 5 and 6. No, that's between 5 and 6 years. And you 5 and 6 years. And you probably say, why are you writing that down? So that I won't choose it. So now I can say, okay, I know for sure it's not my answer. Because that was a false statement. It's not between 2 years. It wouldn't be in 2 years. It would be between 5 and 6 years. So that was a false statement. Okay. The population of the town will increase and then decrease. Now I'm going to use what we call common sense. If I'm adding continuously and I'm squaring numbers, I'll never get a negative because I can't get a negative when you square that number. So this right here, it will never decrease. This is impossible. Okay, so I know that's not even possible. So I know my answer is G for sure without a doubt. Okay, then I move to the next one. And you probably say, oh my gosh, you're doing it. It's really simple if we use table. Yes, use your table. Think about things. Don't just choose answers and just saying, oh, it's this, or don't want to read it. You read it. You read it and you just go through and mark out things and really understand what you're reading. Read for understanding. So number 5. It says the mapping below represent all of the points on the graph of function f. Okay. So really, they're just telling me this is a mapping. I'm marking that out because I don't want to go back and read it. And if I don't do that, I'll go back and read it. And it's not necessary. I don't need to go back and read it because it's just talking about this picture. Here it said, what is the domain of F? Okay, I know X is the domain. I know F of X is the range. Okay, because X is independent and F of X is dependent. Okay, so here we go. So now let me look. The domain. When I look down here, what jumped out at me, and you may, now in this case, you may want to say, okay, domain. You may want to match that up so you can remember this. Stay focused there. Domain, and you know that's domain, so you won't choose the incorrect solution. So here we go. This jumped out at me, that 5. Because I'm like, if you look at the domain, it's what? You know what they did? They count 1, 2, 3, 4, 5. So you could choose. Don't. Really? You think I'm going to fall for that? Really? No. You have to talk to the paper sometimes, but not out loud. Okay. So here we go. The name of the function. So we got here -4, -1, 0, 2, 7. This right here, it checks out. I know my answer is F. Okay? But I'm going to go through and see how they did the other answers. Okay? So now I got here -5, -4, wait. -1. Oh my gosh, this is the domain and range. And they didn't ask me for the domain and range, and we wouldn't write it like that anyway. So I know this is no. Okay. Here, -5, 0, 1, 2, 4. This is the range. And they didn't ask me for the range. They asked me for the domain. So all of this other is not my answer. So I know for sure my answer is F. Okay. So guys, what I'm going to do now, I'm going to stop this review. And I'm going to let this be part 1, and I'll make a part 2. Love you guys, but keep in mind, just go ahead and go through the thinking process. Go through the thinking process. That's how you're going to succeed at any word problems or reading for math. You got to go through the thinking process. Don't rush the answer. Go through the thinking and know why you chose what you chose. Okay? I'll make some more parts. Love you guys. Have a great day.